ACI, the Network Made Simple learning series. In this video, we will cover Module 3.1, Configuring Logical Connectivity in the Cloud, Chapter 3, Cloud ACI Overview. As covered in the previous chapter, Cloud ACI can be a great asset to accelerate cloud migrations and hybrid cloud deployments, providing the same configuration, security, and operation model across multiple on-prem and cloud environments. The good news? You already know ACI. Therefore, I will show you how, using the same knowledge you have, you can easily deploy a production-grade cloud network, leveraging automation and enforcing security consistently. But before we get started with step-by-step configurations on each cloud, let's briefly cover how Cloud ACI works by comparing it to the on-premises version. Let's start with the APICs. If you remember, the APICs are 1, 3, or more physical servers or a mixture of physical servers and VMs for small environments. Each APIC cluster represents an ACI site, which consolidates the management of multiple spine and leaf nodes running in a single pod or multi-pod configuration. Remember, APICs provide a single GUI, CLI, or RESTful API and may integrate virtual and container networking as well. Now, if we compare it to Cloud ACI, you just have to go to your cloud provider's marketplace, in this case AWS or Azure, and subscribe to the Cisco APIC service in a specific region. This will automatically deploy a cloud APIC running as a VM or instance in the cloud you choose, and through it, you can consolidate cloud networking management either through the GUI or RESTful API for multiple regions in a given cloud provider. The whole setup is automated. Therefore, as we will see, you just need to answer some basic questions, and after a few seconds, your cloud APIC is ready to be used. If we go back to the ACI on-prem version setup process, you may remember that we use the starting setup utility and setup wizard to perform the initial APIC configuration as covered in Module 1. For the starting setup utility, we would connect to the APIC server via KVM to answer a few questions like fabric name, password, BTEP pool, and a few more. Now, if we compare that to the Cloud APIC setup, we have to answer similar questions as part of the APIC subscription process. Although we will go through all this in more detail as part of the configuration chapter for each cloud provider, the main things worth noticing are 1. The infra pool, which is similar to your VTEP pool if you compare it to the on-prem version, and which is used as CIDR block to provide private IP addressing to your APIC and other instances that may need it. And 2. The key pair to use. If you remember, in the previous chapter we said that in the cloud, you will need a key pair in order to access an instance or VM via SSH. And Cloud APIC is no exception, since it is running as an EC2 instance or Azure VM, for example. You will also need to specify if there are any specific networks where you want this APIC to be accessed from. In my case, I will just leave it to 0000/0 to allow access from anywhere. Once you hit deploy, you will see a fully automated process happening in the background, and in a few seconds, you have an APIC running in the cloud of your choice, which you can access by simply using the public IP of your newly created instance. Easy, right? However, there are a few things happening behind the scenes that made this so simple. For example, in the case of AWS and using my AWS account, when I clicked to subscribe to the Cisco Cloud APIC service and selected a region, an EC2 instance was automatically deployed, which had a couple of EBS drives automatically curated and attached to it, and a couple of network adapters as well, with their corresponding private and public IP addresses for internal and out-of-band management connectivity. All the networking constructs Cloud APIC would need to communicate were also automatically created, including the VPC, Internet Gateway, CIDR blocks, subnets, routing tables, and security groups, along with the corresponding rules to provide secure access. Finally, other things that were automatically created as part of the initial deployment process include IAM roles and permissions so that Cloud APIC can execute configuration changes on behalf of this account. All this was fully automated by Cloud ACI, leveraging AWS CloudFormation. If you're curious about all the things that got automated, you can click on the Built-in Designer button before deploying Cloud APIC, where you can see all the different cloud-native services that are being automatically deployed for you. There are other services that get automatically configured as part of the process, such as S3 buckets for log and file storage purposes, as well as SQS and CloudTrail. As mentioned before, if you need to access your Cloud APIC instance via SSH, keep in mind you will need to use the key pair you define in the deployment settings, So make sure you keep the private key somewhere safe. On the other hand, if you use Azure instead, all you need to do is subscribe to the Cloud Apex service in a specific region using your Azure subscription and resource group. And a similar automated process will happen for all compute and network services Cloud Apex requires. It also includes the deployment of storage and other specific services needed. And, unlike AWS, there are a few things we will need to do manually in terms of permissions that we will cover in more detail once we configure Cloud ACI on Azure. Just like with AWS, a key pair defining the deployment settings will be needed if you need to access your Cloud Apex instance through SSH. If you're using Google Cloud instead, Cloud ACI will also support it in a very similar way very soon. I will upload a video on how to configure it when it happens, so stay tuned. After the APIC is up and running, we would normally continue to discover spine and leaf nodes if we were running on-premises. However, in the cloud this is a little bit different, since we don't know what hardware or switches each cloud provider is running. We want to maximize the usage of cloud-native services without dictating which switches or hypervisors you should use in the cloud. Therefore, Cloud ACI runs on the cloud provider's infrastructure natively, normalizing, automating, and securing each cloud provider's connectivity model using their own services across multiple regions. By following this approach, there is no need for you to sacrifice any cloud services, since you are directly using each cloud provider's hypervisor and infrastructure. So, you may be wondering by now, how does ACI automate and secure cloud connectivity if we don't have any spine or leaf nodes? Well, as you may remember, each cloud provider has multiple regions and availability zones globally. In the case of AWS, ACI automates and secures cloud connectivity across VPCs and regions through a single Cloud APIC, which automatically deploys and configures VGWs and CSRs if you choose to use a hub-and-spoke model, or transit gateways if you prefer. In terms of licensing, you just need to choose the right option for each Cloud APIC you deploy based on your needs, defining how many instances or VMs you need to connect. For a single Cloud APIC deployment, you would only need the Essentials license. For multiple clouds or APICs, you would need the Advantage license. And finally, you would use Premier if you want to include Nexus Insights as part of the Nexus dashboard for your cloud environment. Nexus Insights, running on Nexus Dashboard, provides artificial intelligence-based network telemetry and analytics. As of 2020, Nexus Insights is available for on-prem environments only, but public cloud integration is expected in 2021, which will deliver hybrid cloud visibility and a proactive operational model across clouds. We will cover Nexus Dashboard and Insights, as well as how it integrates to ACI in Module 6. Now, if we take a look at Azure, the same concepts apply, where Cloud ACI automated deployment options for VNet and region connectivity include VNGs and CSR 1000Vs, when hub and spoke is the desired model, and VNet peering with CSR as the preferred option. As you would expect, the same licensing model also applies here. Just like with the setup wizard for spine and leaf auto discovery on premises, we use the same setup wizard once Cloud APIC is ready, in order to define with a few clicks which regions can be centrally managed. We also configure which automated connectivity model we want to use, as well as other settings such as DNS, NTP, and BGP autonomous system, which we will configure in the next chapters. Once we're done, this is pretty much ACI business as usual, but simpler. Unlike on-premises ACI, where we first learn how to configure both the physical network or access policies and then the logical network, Cloud ACI does not need any physical network configurations. Why? Because as you may remember, the cloud provider is managing and configuring their own switches and routers so that you don't have to. However, you still have to define how you want to connect different instances and services in the cloud, and therefore, the logical network configuration is still needed. You will be configuring your tenants, EPGs, and contracts pretty much the same way as you know them on-prem, which will allow you to normalize your network operations. ACI will take your configuration and create the corresponding cloud-native objects on your behalf automatically. This way, we can follow our 5 steps to configure the logical network, just as we learned before. However, there are a few minor differences and considerations you need to know about. So, join me in part 2 of this chapter to briefly go through them.